All right, multiplying and dividing monomials. Let's go. Okay, just two quick things. First is product of powers. Two concepts. You can multiply powers with the same base by adding their exponents. So if I have a base of a, and I take m and n, I just add the two together. So 3 to the second power times 3 to the fourth power, I can change that to 3, and 2 plus 4, which would make 2 to the sixth power. Fairly straightforward. If the base is the same, add the exponents. Okay, quotient powers. Oh no, it's fractions, everybody run! Just kidding, it's not tough. You can divide powers with the same base by subtracting their exponents. So if I have the same base, m over n, I can change that to subtracting them. So 5 over 4, or 4 to the fifth and 4 to the second would end up being 4 to the third. So if the powers are the same, as long as the base is the same and they're dividing over top of each other, subtract the powers. Hopefully that's fairly simple. Let's look at some examples. All right, find 4 to the third and 3 to the sixth, or times 3 to the sixth. Well, we know that if it has a common base of 3, that we can add the exponents. So we change it to 4 times 3, 3 to the 4th plus 6. So 4 plus 6 is 10 when we add the exponents, so 3 to the 10th. Now we can check this out. Here's what I probably should have had on the last slide, was when you have these together, I'd have 3 3s in a row and 6 3s in a row. And really that's just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 3s there. So we can just rewrite that as 3 to the 10th. So it checks out when we write it all the way out there. So 3 to the 10th would be my answer. All right, so you try that one. You can use either method. You can write it all the way out, or you can just add the exponents. Go. All right, so we just add the exponents. So 4 to the 3 plus 5 would be 4 to the 8th. All right. Y to the 4th times y. Well, there's no exponent on there. Oh, wait, is there? Remember a couple of lessons back, when you have a y by itself, there's technically 1 there. So technically the common base is 1, or is y, and you can have 4 plus 1, which would be y to the 5th. So if there's 4 y's times 1 y, it'll be 5 y's. Y to the 5th. You could also think of this as if you had the 4 y's like this times y, that there would just be y to the 5th. All right, let's try this one. A little more complicated here. So first we use the commutative property and the associative properties to pull the 3 and the -2 out. And then we can compare the p to the 4th and p to the 3rd. So from there we can multiply the multiply 3 and -2 to be -6. And then we can rearrange this so we can see the exponents to add. And then we can combine them all together, -6p to the 7th. So -6p to the 7th. All right, find each product. Go. All right, well, I've got 2 w's times 5 w's. So I can take w2 plus 5. It's going to equal w7th. Down here, here's how I think of this, is I'm going to take -4 and 6 is going to be -24. And then m and n, I can take m and 3 plus 2. So that's going to be -24 m to the 5th. I probably just covered up the answer. W to the 7th, 24 m to the 5th. Sorry, I covered that up. Moving on. Find 8 to the 11th and over 8 to the 5th. Well, we said earlier that when you have a common base, that you can, and they are division over each other that you can subtract them. So 8 to the 11th minus 5, which will go to 8 to the 6th. What they didn't probably show you, and this came from yesterday, is if I wrote all these out, if I wrote 11 of these, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and I put that over 5 of these, 1, 2, 3, 4, 5, I can cross out that many of them. So I can cross out 5 of them. That leaves me 1, 2, 3, 4, 5, 6. So that's where the 8 to the 6th comes from. Find 8 or x to the 12th over x. They're trying to do that whole trick thing again. There's one x. So you can either think of it as write a 12 x's here, but I don't want to do that. So 12 minus 1, which will give me 11 x's, so x to the 11th. All right, pause this one and give it a shot. They were so nice to you. So it would be r to the 4 minus 1. They even called it a 1 here. They were so nice. R to the 3rd. All right, so this is what a word problem could look like. I think you'll have one on your homework. If you fold a sheet of paper in half, you have a thickness of 2 papers. Folding again, you have a thickness of 4. Continuing in half, recording the thickness. How many times thicker is a sheet that is folded 4 times than a sheet that has not been folded? So write a division expression to compare that thickness. So 2 to the 4th would be folded 4 times over 2 to the 0. So 2 to the 4th minus 0, if we subtract the exponents, would give me 2 to the 4th, or 16. So we can say that paper is 16 times thicker. And we'll skip that one because we can. That's it.